So in today's video, we are going to look at the JEE Advanced PYQs of limits, and I have also included one PYQ from derivatives. And in the upcoming videos, we will do this chapter wise. So for today, the chapter is limits. And we will look at some specific problems that I've handpicked. So I suggest you take a pen and copy, pause the video and try to do it yourself. You can try to just get the answer or even do the calculations, and then we will go through it here. So first of all, the first question is, let k be a real number and we are given this limit x tends to 0 sine of kx plus cos x plus x whole to the power 2 by x, and the value is given as e to the power 6. We need to find the value of k. Now, whenever you are given a limit of this kind and you see there is a variable power upon the whole expression, you simply need to take logarithm always. That is the only way this problem is going to work. And this is the easiest way possible. So we define the limit as L, and this is the statement basically. Now, what happens when you take log? So when you take log, basically, it becomes 2 into logarithm of whatever there was in the numerator, the whole thing basically, and then 2 by x comes out as a coefficient. So you can see here 2 into ln of sine of kx plus cos x plus x whole divided by x. And on the right hand side, we have ln of e to the power 6, which is nothing but 6. Now, notice that this is a 0 upon 0 form. If you put in 0, it becomes sine 0 plus cos 0 plus 0. And since cos 0 is 1, so this basically gives you ln of 1, which is 0. And that's why 0 by 0 form. And what we do whenever we have a 0 by 0 or an infinity by infinity form, we do lapita. So that is what I have said repeatedly in my videos, that if you have a limit and you have a 0 by 0 form, which usually it is, you should always apply the lapita. So when we do that, we apply chain rule because first of all, the derivative of x is simply 1, which I have denoted here. And for the numerator, we have 2 as it is because it's a coefficient. And then ln of whatever there is, the differentiation of ln x is 1 by x. So you have the whole thing here in the denominator. And then you simply have cos of sine kx into a into cos of kx. This is the differentiation of the term sine of kx. Then for plus cos x, you have minus sine x. And then for plus x, you have plus 1. You can see how easy this becomes once you do the derivative here. And now simply put the values, because you can check that the derivative is no longer indeterminate, the limit basically. So we can put in the value, and once we put the value, it becomes very simple because cos 0 is 1 and sine 0 is 0. So simply what you have is 2 into k plus 1 equals to 6. Cancel off this 2 and 6, you get k equals to 2. Option B is the correct answer. So you can see a JEE Advanced problem like this can be solved. This took some time because I was explaining, but once you understand what to do, you can rush through the steps and do it under a minute even. So even JEE Advanced problems can be done like that. So in the coming problems, they can be longer, but they will never be something that you cannot do under a minute or two. So for the sake of explanation, I've made it longer. So for this problem, it is worth remembering that sin n by n as n tends to infinity is 0, although we are not going to use it, but you might find it somewhere in other problems where you can use it. Also, this is true because of the squeeze theorem or the sandwich theorem. Now, let's get to the problem. This is our given limit, and remember we have limit x tends to infinity and not 0. Now, first of all, I'm going to separate it like this: sine of x square by x square and x square into sine of 1 by x square. Now, this part is one, which I'm going to explain in a bit. And then you have the rest of the part, which we can call px, this whole thing. Okay, so this whole thing, the third part we can call px. Now, the second part is 1 because you can basically make the substitution y is equals to 1 by x, and that really turns it into limit y tends to 0 sine of y square by y square. Because when you do y equals to 1 by x, 1 by x square becomes y square and x square becomes 1 by y square, right? And you get the answer 1 because this is a standard limit. And also sine of x square is finite. So this term here is basically finite because the thing is the value of sine is always bounded, because the amount of sine of x square is less than equals to 1, does not matter where it goes, whatever real value of x you have. So that means we do not need to worry about that term. Whatever it contributes, it does not matter because it is not going to make the limit blow up. So the term we are left with is basically px upon x square. If you remember, we had an extra x square here, which we adjusted to get x square in the numerator with the sign of 1 by x square term. So you have this whole px term here and you have the x squared term here. So we need that as finite because otherwise we cannot have the value 0. That needs to be 0, right? Now, so our expression completely turns into this, that we have this px by x squared. And now what I did was I tried to adjust this ln x to the power alpha, and I wrote this as ln x to the power beta into ln x to the power alpha minus beta so as to combine it with the logarithm in the denominator. Once we do that, we get this term here multiplied by the rest of ln x, which is ln x to the power alpha minus beta, divided by x to the power alpha beta plus 2. The plus 2 comes from the extra x square in the denominator. Now, this is again 1 because you can do Lapita again and find out that this is 1. It should basically be 1 by x and 1 by 1 plus x, which is simply 1 upon x tends to infinity. Remember, this is an infinity by infinity form, and that is why we can still do Lapita here. Okay. So we are now finally left with the final term. And just a simple substitution like u equals to ln x will give you a very known form where x equals to u to the power u. And you should get this form. Now, any polynomial divided by any power of e is always 0 as long as the power of e is positive. This is a very standard result. And in order to maintain that, we need to ensure that this alpha beta plus 2, because u is already the limit variable, it is go tending to infinity. This alpha beta plus 2 must be greater than 0. That is the only way we are going to make this form. So we only need to find out if alpha beta is greater than alpha beta plus 2 is greater than 0, which means alpha beta should be greater than minus 2. And only two such sets satisfy where alpha beta would be greater than minus 2. So B and C are our answers. Please go through this problem once again on your own and understand that the only difficulty here lies in the fact that you need to understand that you have to adjust the logarithms. Otherwise, everything else is just simple here. Okay. Let's go to the third problem. Let fx be a continuously differentiable function on the interval 0 to infinity such that f of 1 is 2 and this limit is 1 for each x greater than 0. Then for all x greater than 0, f of x is equal to, we have to find the value of f of x. Okay. Now, this is again a very simple problem. You're given f of 1 is 2 and f is continuously differentiable, which is very important because its derivatives are also continuous. We are going to require that. Not really in this, like we require that if we were to solve a subjective problem because you could use that fact. But since this is an MCQ, we are not even required to give any logical explanations for that. So you can just move forward. Anyway, this is a 0 by 0 form. As expected, we can just simply do the differentiation. For numerator, you can see the variable of limit is t. So basically, we do differentiation with respect to t. The first term becomes this 10 t to the power 9 into f of x, where f of x is simply a constant. And then this becomes f dash t because x to the power 10 is a constant. And in the denominator, we have 9 into t to the power 8. Now, it's no longer in a 0 by 0 form since we already did the differentiation. And now we can simply put the value x and we can simplify the things like this. Now, we will try to bring it in a linear ODE form. So basically, after we rearrange like this and make the coefficient of the leading term of f dash x as 1, this is the form we have. And this resembles that of the ordinary differential equations of first order. So these are linear differential equations, right? What we do in this kind of an equation, we find the integrating factor. What is the integrating factor? So the integrating factor usually is the coefficient associated with f of x or y, whatever you write in terms of f of x, you can also write y here. So the coefficient is minus 10 by x. So the integrating factor should be e to the power integration of that function. So basically e to the power integration of minus 10 by x dx. This is a pretty simple integration because you can see 1 by x dx is nothing but ln x. And in this case, you do not need to include the constant plus c, you simply do need the antiderivative of this function. Now, minus 10 ln x is nothing but ln of x to the power minus 10, as you know the property of logs, and thus you get this as the integrating factor. Once you get the integrating factor, the value of fx is pretty clear because the formula then says that integrating factor into the function should be equal to integration of whatever was there in the right hand side to begin with, multiplied by the integrating factor, and you have to integrate that. So what basically is that if, which is the integrating factor, into the function f of x should be equals to integration of, let's say there was a function h of x on the right hand side, that function into the integrating factor, and we have to do the integration. This is the formula. So you would know it from the basic theory of ODE that has been covered in your syllabus. And once we do this, this is a very simple integration. It simply gives you 9 by 11 x to the power minus 11 plus c. And now to eliminate c, we use the fact that at x equals to 1, f of 1 is 2, which means the c value is 13 upon 11. And now from this, we multiply x to the power 10 on both sides to get only f of x. And we get f of x equals to 9 by 11x plus 13 by 11 into x to the power 10, which we can check is option B here. So this is our correct answer. So let's move on to the next one. Now, again, a question, but this one also involves the use of sandwich theorem or squeeze theorem. So whenever you have limit and this kind of problems where you have an interval specified like this, you have to understand you need to find out the limit on both sides usually, because both of them should give you the correct answer. So not for g of x, but for this one. Okay, we'll see what I mean. So f of x is given as root n when x belongs to 1 by n plus 1 to 1 by n for all n, and because it's a function between like 0 to 1 to real numbers. And then g is also defined like this function where we have bounds, upper bounds and lower bounds for all x belongs to 0 to 1. You have to find the limit of limit x tends to 0 f of x into g of x. Okay, so anyway, so these are the definitions, right? These are the definitions. Now, we what we can do is we can understand that if we were to find this value, a simple like a simple lower bound could be this, right? But we are not interested in a simple lower bound because g of x is greater than this limit, right? This integral. So obviously we can employ this and understand that, okay, limit x tends to 0, f of x into g of x should be greater than limit x tends to 0. In place of g of x, we put the function which g of x was greater than, that is this limit x squared to x integration root over 1 minus t by t dt, there should be a dt, into f of x. But in order to do that, we also need to find out the bounds for f of x. Now remember that you had 1 by n plus 1 less than equals to x less than 1 by n, right? From this, you can do the reciprocal and find this relation. And from this, you can find root n is greater than root over 1 plus 1 by x minus 1. Now, the thing is, if you were to calculate limit x tends to 0 minus, that would not exist. That is why we are here calculating limit x tends to 0 plus, because we have root x, right? Whenever root x is involved, you cannot calculate something on the negative side. So that is why we are calculating this limit rather. So limit x tends to 0 plus fx gx then should become the lower bound, that is this thing is greater than. So gx is greater than this and fx is greater than this. Okay. And similarly, you can also find out the same thing using q. Now, for q, you can get the limit like this. Q is very easy to get because root x and root x cancel off. And if you put x tends to 0 plus and root over 1 minus x, you get 2. Similarly, for p, that's the lower bound basically. For p, you can do the same thing. Now, for p, if you see here, we had a root over 1 minus x, but in limit x tends to 0 plus, root over 1 minus x is simply 1. That is why I have omitted that term here. So we simply have this thing here. Now, if you remember how to differentiate under the integral sign for integrations which have variables as limits, we use the Leibniz rule. I have explained this in other videos. You can see those videos. So this basically gives you derivative of x into the function x plugged in here. So that is this minus derivative of x square, which is 2x into the function x square plugged inside this, divided by the derivative of 1 by 2 root x. This is because this was a 0 by 0 form. So we differentiate it. And now simply you can put the values. So this is the value and that gives you 2. And since both the lower and upper limits between which the limit lies is basically 2 by the squeeze theorem, the answer must be 2. So another problem which could have been done, I think it would take at least 2 to 3 minutes minimum. But if you're very much clear, if you have clear concept about the squeeze theorem, you would recognize immediately from the problem that, okay, I need to apply squeeze theorem in order to get both the bounds and the limits for those bounds for fxgx. Okay, let's go to another one. Okay, this is again a simple one. So what you basically do is you first write the limit like this. The numerator does not matter. I've just simply expanded it. In the denominator, I did x square and 1 by x square to make this x cube. And more importantly, make this one sine square x by x square. Because this is nothing but sine x by x whole square, which is essentially 1 when as x tends to 0, correct? That is why I have done, because this term vanishes. Now you can see you simply have x cube left because this term is 1. And now you simply add a minus 1 and a plus 1 here. So e to the power x cube minus 1 by x cube. Why am I doing that? Because this is a standard limit, if you remember, which is equal to 1. And the plus 1 is added to this one. And combined with it is 1 minus x cube to the power 1 minus 1 by 3. And then you have minus sin x common. And also the x cube has been distributed like x and x square. Just carefully watch this step. So I've written minus sin x common. Inside we have 1 minus x squared to the power half. And I have given 1x to the sin x and the other 2x's to this term here, right? And this is because this sin x by x is also 1, as you can see. This is also 1. So we are basically left with something like this 1 plus limit x tends to 0, something where you have the cube and something where you have the square. Almost identical quantities. Now, these are again 0 by 0 forms, differentiate once, and you can see that this term's cut off, and x tends to 0, 1 minus x cube is 1. Similarly, here, this term's cut off, and x tends to 0, 1 minus x square is 1. So what you simply have is this step and now put in the values and you can get 1 plus 1 by 3 minus 1 by 2. Simplify to get 5 by 6 and this is the value of beta if you remember. We need 6 beta, so obviously 6 beta should be 5 by 6 into 6, right? Which is 5, which is our required answer. Another simple problem, and even if you wanted, you could have like did the differentiation directly here. But it's better to just eliminate the sine square by x square term first and then do the differentiation because that would save a lot of efforts. Okay. Now we have another problem here, and this is a problem from differentiation which I was mentioning in the beginning of the video. So this kind of problems are very tricky and calculative. So that is why I've explained in detail so that you do understand all the steps here that are involved in order to solve this problem. Watch this carefully. We have f of x here, and we have g of f of x as x, and then we have h of g of x equals to x. Do not be confused by the definitions. Just understand them carefully and apply the rules blindly. Do not try to think if this is going to lead you to the correct answer or not. First of all, let's check this. To check that, we will first do g of f of x equals to x, this thing, and we apply chain rule and find the derivative on both sides. We simply get g prime of f of x into f prime of x equals to 1. Now, g prime of f of x then should be 1 by f prime of x. And what is f dash of x? Well, this is very easy. F dash of x should be the derivative of x cube is 3x squared. The derivative of 3x is 3 and for 3 is 0. So it's basically 3x squared plus 3. And we got it. And now you need g prime of 2. So that means you need such an x such that f of x becomes 2. Now you can see simply that f of 0 is 2. So we simply put x equals to 0 in this equation. And you get g prime of 2 is 1 by 3, which is not 1 by 15, right? Okay. Now let's go to try on this one, I think. G of f of 0 is 0 because you can put any value of x here in this equation. G of f of x equals to x, which gives you g of f of 0 is 0. And now since f of 0 by the definition of f should be 2, we also get g of 2 is 0, which is important. And now we are trying to understand the values of h. Okay. So this is the equation given, right? To get h of 0, which is what asked in the question, we need h of g of 2. Why? Because whatever g value of x we put, we need this gx to be 2. We need this gx to be 2 so that we have g of 2 equals to 0. And thus we finally have h of 0. So basically this g of something should be 0. And that is how we are going to get h of 0, right? So we need h of g of 2. To get 2, we need x such that g of x equals to 2. Understand this step carefully. So g of x should be 2. Since g of f of x equals to x, we can say that g of f of 2 would be 2 by putting x equals to 2 here, right? And what is f of 2? F of 2 is 16. Now, just put x equals to 16 in this one. So h of g of 16 is equals to 16 in this equation, right? If you do that, you simply get, since g of 16 is nothing but 16 is f of 2, as you see, g of f of 2 is nothing but 2, according to the relation g of fx, right? Sorry, not g of f of fx, g of f of x equals to x. According to this relation, whatever you put in here as x comes out itself. So g of f of 2 would be 2. That leads us to this step, h of g of 2, but g of 2 is 0. So we simply have h of 0 equals to c, and thus c is correct. Again, for g of x equals to 3, we need such an x such that x is f of 3. So g of x is 3 only when x is f of 3, right? And f of 3 from the definition of the function f is simply 38. Again, if you put that, you simply get h of g of 38 equals to 38 from the relation 1 as we wrote. And since g of 38 is nothing but 3 because 38 is f of 3, we get h of g of 3 is 38, which is not 36. So that option is also not correct. And lastly, we can differentiate that again using chain rule to get h prime of gx into g prime of gx into g prime of x equals to 1. Now, since f of 1 equals to 6, we have g of f of 1 equals to 1 and x such that g of x equals to 6. So f of 1 is 6 by definition and g of f of 1 is 1 because from the definition of g of f of x equals to x. We need such an x such that g of x equals to 6 and we already know such an x is basically f of 6. We already know it from the definition of g of f, g of x. So f of 6 is basically 236. You simply put the value 236 in this equation and you get this huge equation, but where you do not really need to solve the values for. Just simply need to understand this equation, right? Now, what is g of 236? Now, since 236 is f of 6, it is obviously g of f of 6 is simply 6. So this thing here becomes 6. Similarly, this becomes 6. So you simply have h prime of g of 6 into g prime of 6 into g prime of 236. Again, since g of 6 is 1, because we just found out that f of 1 is 6, so g of 6 is nothing but g of f of 1. So if you have confusion, g of 6 is nothing but g of f of 1 equals to 1, then this is basically equals to h prime 1, which is what we want, into is equals to 1 by g prime 6 into 1 by g prime 236. Initially in the problem, we already determined what is this, what is the formula for g prime of f of x. So now we simply put x equals to the values required. So x equals to 1. So f of 1 is 6. So g prime 6 simply becomes 1 by f dash 1, which is 1 by 6. And in a similar way, if you put x equals to 6, this becomes 236. And you get this as 1 by 111. So since these are reciprocals and in the answer we also have reciprocals again, h prime 1 is 111 into 6, which is 666. And thus B and C are the correct answers. So we did a few problems from JEE Advanced PYQs here and we understood all the steps. But it is very necessary that you also practice it on your own. Apply these formulas, apply these techniques. And for limit problems, you need to be very sure about the techniques you're using in Lapita, if it is 0 by 0 form or not, if it's an infinity by infinity form or not. You need to check that. So these are very sure shot marks in JEE Mains and Advanced both. So do not get this wrong. That is why I'm repeatedly telling in calculus, do not get any answers wrong. That is why these videos are for, to help you understand. And there would be many more videos coming up on these topics and on other topics like algebra, probability, statistics, coordinate geometry, vector 3D and stuff like that. And I hope you like this video. So please let me know in the comment section if you like this format, which I'm using right now. And if you need some chapters before the others, please let me know the order of those chapters so that I can do them accordingly. So thank you. And also, if you're new to the channel, please do subscribe. We'll see you in the next video.